Good afternoon, everybody. Thank you very much for taking time out of your busy reInvent schedules here late on a Thursday afternoon to come to our presentation for incident response in the cloud. My name is Jim Dennis. I'm Solutions Architect for Amazon. I work in the worldwide public sector federal space, and I support customers both in the Department of Defense and federal civilian agencies. I'm joined today by my colleague Conrad Fernandez, who's the cloud cybersecurity lead for Johns Hopkins Applied Physics Lab. Basically, this presentation for the next 60 minutes divided up into two halves. The first half, we're going to give you some basic level setting for events and incidents, things that might go bump in the night, some incident response in the cloud best practices, and then the real meat of this presentation is in the second half, where Conrad's going to come up and present an actual case study for how Johns Hopkins Applied Physics Lab handles cybersecurity and incident response in the cloud. So that said, first, basically, what's an incident? It's a basic definition from ITIL that all events are not incidents, or all incidents are not events. And in event management, we take a look and monitor what is occurring events in the cloud. And when we classify one that comes up with an incident, then we trigger the incident management process that it goes into action. So an incident, if you look at the ITIL definition, is an unplanned interruption of an IT service or a reduction in quality in an IT service, or actually even a failure of a configuration item that's not yet affected by affecting a service is also an incident. For example, if you were running Amazon RDS, MySQL, and you had configured several read replicas of that, and one of those read replicas had failed, even though you didn't experience a disruption in service, that failure, that configuration item would be considered an incident under the ITIL definitions of it. So what we're talking about in incident response in the cloud is a procedure that it should be very familiar to you for incident response on premise in any environment with some differences. Bottom line up front, what we want to tell you, is that there's no rocket science involved. You can have a very complex nature of response to an incident, but none of this should be unfamiliar to you in the cloud as opposed to what you're used to on premise. As far as incident response ownership and governance and control is concerned, if you are familiar with Amazon Web Services, you'll be very familiar with our shared security model, where Amazon is responsible for the security of the cloud, you are responsible for the security in the cloud. And that, what your governance organization, whatever certification accreditation standards that you need to apply to your workloads will govern which controls and security and what your incident response policies and procedures are going to be. It could be, in the case of my federal customers, it could be FedRAMP or DoD Risk Management Framework. It could be SOC, could be PCI, could be HIPAA. And in each one of those certification regimes, there's going to be policy, process, procedure, and governance that will be guide you and prescribe how you handle incident response in the cloud. Basically, when we talk about incident response in the cloud, we're looking at 4 potential scenarios or domains and understanding the interfaces and boundaries of those. So for example, under that shared security model, you as a customer would be responsible for incident response of the infrastructure and services in the cloud that you use. There can be also incident response for us, Amazon, as a cloud service provider. So for example, we have to prescribe, for example, in the federal government, we have a prescription that says for maintaining our authority to operate and our accreditation, we have to make sure that we're responding to incidents and security and patching of the infrastructure we own. So that's the domain of us as a cloud service provider. Finally, there are some joint domains that are involved or may be involved in incident response. You may have an incident that occurs that requires joint coordinated incident response on your behalf as a customer that also involves us as a cloud service provider. And we'll get into that a little bit further in the presentation of how you should approach those kind of things. And then finally, the last procedure may be rare, but certainly possible. For example, a 0-day that may be identified across infrastructure that's used by multiple cloud service providers. You could have a incident response that requires response from multiple cloud service providers, AWS, Azure, Google, et cetera. Those are those 4 domains that we consider an incident response in the cloud. In any case, whatever your domain of certification, accreditation, and security and incident response is, you are going to have some applicable governance standards. What I have here is the examples from the federal government. So in the federal government community, we have the NIST 853 framework that governs federal systems, NIST 800-171 that governs the controls, security controls, and incident response guidelines for government data hosted in contractor systems. Similarly, FedRAMP that governs all cloud service providers that sell services to the federal government. But in any case, you will have one of these requirements, whether you're having a SOC application, PCI, HIPAA compliant application, you are going to have an accreditation regime. Your homework assignment to develop your incident response plan is to learn what those requirements are under the framework that governs you. Stakeholders in incident response, this is another example. This is from the federal government, but in every case, you are going to have stakeholders that are involved in incident response. In this case, we're illustrating what happens in the federal government. We have the FedRAMP Program Management Office, involvement by, for example, a government agency, us, Amazon, as a cloud service provider, the third-party assessing organizations that audit us, and incident response coordination. Your stake in that is in all of those areas. You will be involved in incident response with potentially the cloud service provider, potentially your company, or in our case in the federal government, a government agency, the overarching organization that's doing your accreditation and coordination of that. Similarly, there is governance applied to the organization. This is an example from the federal government where in cloud service providers, when we talk about incident response in the federal government, and this will be the same in your accreditation regime, all of these various entities are involved in establishing the government, all the way down from the Office of the President of the United States through the Department of Defense, Department of Homeland Security, NIST in this case, which National Institutes of Standard and Technology that develops the control regimes and standards that you use. And you can substitute, in the case of a federal agency, whatever you have in here for your particular business that governs your accreditation standards, putting your own policy and procedure. So for this particular presentation, this is an example from there are 18 control families, security control families within the NIST framework when you certify and accredit a system under NIST. Cloud service providers have to comply with 17 out of the 18 certification control regimes. The only one we don't have to do is program management because we're not a federally managed program. But for incident response, there are 9 different families of controls in which you have to implement whatever your response is to handle an incident. In this case, with what we're doing today for incident handling and spillage, we're going to look at what IR4 and IR9 looks like for apps for implementation. So let's talk about incident response in the cloud. What do we need to think about? Our CTO, Werner Vogels, says famously and often, everything fails all the time. And so what you have to do in incident response is to prepare for everything to fail all of the time, because incidents are guaranteed to happen. And the better you are prepared up front to handle those incidents and respond to those incidents, the more effective your incident response will be. And what we're going to advocate today in some of these best practices is, rather than a reactive incident response, is a proactive incident response of integrating into your continuous improvement programs. So what are we going to talk about today? What's different, what's similar about the incident response in the cloud? Talk about building IR policies, governance plans, procedures, and runbooks, preparation, training, and execution. And these 3 down here, continuous improvement, IR exercise, and iteration and automation are probably three of the most important things that you can do for incident response in the cloud. As I said, rather than being reactive, being proactive and integrating incident response into a continuous improvement process. And then finally, engaging your cloud service provider, in this case AWS, when you need us to help you with incident response. So let's go over some of these best practices. Cloud considerations. So what's different in the cloud? Cloud is different. IR in the cloud is different, and it's different in fact primarily in it's easier, faster, cheaper, and more effective because of the fact that we provide you in Amazon with the ability to essentially build, define, and control and automate your infrastructure totally in software. You have the ability to automate everything, to monitor everything in real time, to get telemetry back, to identify events, evaluate events, and classify them as incidents or non-incidents in the cloud much quicker, faster, and more effectively than you can in any other environment. Your ability to detect those incidents is greatly enhanced. Some of these capabilities are possible only in the cloud. For example, you may have heard that we released the AWS Guard Duty service. Very, very powerful service that with one click of a mouse allows you to essentially consume all of the telemetry from your AWS account to apply not only signatures, but machine learning and behavioral algorithms to the performance and what's normal for your account to greatly enhance your ability to identify which events are important, which ones are not important, classify them as incidents, and respond. So let's talk about leveraging your, the incident response to improve your security in the cloud rather than being purely reactive. Incident response in the cloud, integrating it in with continuous improvement, I like to make an analogy to the aviation industry. So I happen to have been a pilot for the last 40 years. I've been involved in aviation for a very long time. And one of the things that I've observed about improvements of safety in the aviation industry is the robust nature of incident response and continuous improvement. Every aviation accident or incident that has occurred over my lifetime and certainly before that has been used and rigorously analyzed to improve the safety of the aviation industry. That's the thing that you want to think about in the cloud, is using those incidents and accidents that occur in your environment geared to your AWS environment for continuous improvement every time that they occur. Just thinking of like that's an NTSB accident report. Preparation for incidents, I mentioned for being proactive. When you have an incident response occur, if you are prepared for that instance, if you are prepared for failure, if you are architecting for that with forethought, your response is going to be much, much more effective in enabling you to take care of whatever problems occur. You want to start out by architecting for failure and incident response throughout your environment. One of the things that we recommend that folks do is to implement clear, lightweight governance and ownership principles so that when you design your architecture, you know immediately who's responsible for which pieces of infrastructure, who owns that infrastructure, what the security requirements are, and that can be done very easily by implementing a proactive tagging policy. We'll talk about that in some detail. So AWS has a very robust capability to tag and identify your resources in the cloud. If you use that and design your tagging, taxonomy, and controlled vocabulary with line of sight to your business, however the business is operating, whether that business is segmented geospatially, whether it's segmented by lines of responsibility, you will have in your hands the ability to not only define your identity and access management policy, but the ability to identify the owners of assets, where the incident occurs, and who to contact in order to take care of that. Clear, simple controls and runbooks are a natural result of that kind of approach, where once you know that the architecture has been tagged and your assets are defined and that you have that line of sight back to the business, you can implement very clear, simple, easy to execute runbooks for your responders. You can also implement, as I said, identity and access management policies that implement the least privilege principle throughout, minimizing the accidents that could occur and being able to identify, should an incident recur, where those particular privileges are valid and not valid. And then finally, once you get to the end of the rainbow in incident response, one of the things you might want to consider is automatically introducing failure. Like folks like Netflix have done this in the past, where they intentionally introduce failure in order to enhance their ability to respond and manage incidents and failures automatically. As far as ownership and governance, we recommend that you use the maximum amount of tools that we provide and any tools you have on premise. And as I said before, is this tagging taxonomy that is a controlled vocabulary with line of sight to your business. And basically the rules that we say to live by in this is that you should not have to be an information technology subject matter expert to look at these tags and identify what the significance is to the business. So when you design these taxonomies and to tag your resources in AWS, you should be able to put those on a sheet of paper, show them to the operational folks who are subject matter experts in the business, but not necessarily technical subject matter experts, and have them understand what that asset does, who owns it, who's paying for the asset, what the security requirements are. And however your business operates, for example, I used to work in the US Coast Guard, and when we looked at how the Coast Guard operates, it has several facets of organization. It has a geospatial facet. It's organized in various parts of the country and districts. It has operational facets like logistics, intelligence, these sorts of things. Your business will have the same sorts of things, and you should be able to take your assets and design a tagging taxonomy that defines a business line of sight back to your assets in the cloud. You should have a procedure, and this allows you to engage owners and administrators very, very quickly and efficiently simply by looking at the asset itself and how it's tagged. You should have procedures defined to engage AWS, your cloud service provider, whenever you need to, and they should be clearly defined as to when the checkpoints are as to what responsibilities you have in the shared security model and when you need to kick that over to AWS or escalate it. Finally, most importantly, we see this a lot in customers where there's a lot of paper does not make you secure. And having things on paper is not security. You should not create policies and procedures for incident response or any of these other governance that you are not willing and able to enforce. So if you do not have a policy that a violation occurs, if you're not willing to enforce it, there's something wrong with that policy. So taking advantage of your cloud service provider for incident response in the cloud, the thing you want to look at is how can you leverage all of the tools that your cloud service provider, in this case AWS, makes available to you, and when to engage your cloud service provider. We have lots of tools. As I mentioned, Guard Duty. We have AWS Shield. Guard Duty is, as I said, takes all of this telemetry. It's a very low-cost service. It provides you a lot of visibility and advantages into incident response and how to handle that in the cloud. We have AWS Shield that is automatically enabled and can help protect you from denial of service attacks. All of these tools and services are available to you, and you should leverage them. One of the things that has been a buzzword recently, DevOps, we like to inject security into the middle of that and apply DevSecOps principles to your incident response, being very agile in what you do. Take what you do already very well, start small and grow incrementally. And this is one of the big advantages that the cloud provides you is what I call building an IR flight simulator in the cloud. I know when I was running a data center, we didn't have the money to build simulated environments to blow things up just to test incident response. It was very expensive and time-consuming to do that. That advantage is built into the cloud. You have the capability to essentially clone your environment, train on that environment, blow it up, create incidents and scenarios, and then schedule planning sessions and run IR simulations at extremely low cost. So you can basically create an environment that allows you to learn, to develop your incident response, iterate and improve at a very, very low cost using the cloud. Building an IR, another thing that we recommend is building an incident response scenario catalog. So there's lots of ways to do this. Identifying issues of importance, and you can do either historical based on what you've experienced in your environment before and what if scenarios to create an incident response catalog. Go to the people who know your systems. Leverage, skilled users, your customer base, your security people, your operations people, and build realistic playbooks and simulations that you can run that reflect what actually might happen or what has happened in the past, and develop run the simulation live and complete after action. You can use this in the cloud to improvise your incident response plans and improve them and repeat. And we're here to help. I do a lot of work with various federal agencies on how to do these incident response kinds of playbooks. And under federal requirements, you're required to run these tabletop exercises once a year. And the tabletop exercises are instructive, but they're not nearly as instructive as actually running a real-time incident response simulation in the cloud. Bottom line we're getting here is incident response is no accident. You want to build for speed, agility, and use everything in the ecosystem that AWS gives you. We have a lot of real-time telemetry and metrics that we offer, and you can use those to automate responses everywhere. For example, if you get an alert from AWS Guard Duty that somebody had, or AWS config that somebody has opened a port that's not supposed to be open, you can in real time automate and close that down. As I said before, lightweight governance. Being able to delegate decision-making capabilities down to the lowest level at which the decision can be reasonably made. So in an incident response, you don't want to be going up 3 or 4 or 5 levels of management in order to get an approval to take action on an incident. You want to be able to take what people on the ground, on the floor that know the systems can do, and delegate them the capability to make that decision making, again with that least privilege principle in there. Developing thresholds for engagement of your security people. When does security need to be notified? At what level? When do you need to escalate? And then finally, utilizing secure communications for incidents with the ability to verify and authorize actions. So if somebody comes and calls and says, hey, this network, this VPC connection needs to be shut down, you need to have secure and communications to be able to look at that and authorize that. This graph's already, or this slide's already out of date because we've already introduced multiple new services. I said Guard Duty, as well as other services. But we provide you with a whole range of ability to collect telemetry from your AWS account, to use that telemetry to analyze whether or not an event is indeed an incident, to automate it and take action as necessary, and notify the right people in your organization. So when should you engage your cloud service provider? We say you should engage AWS support anytime you have an event occur that may be affecting your ideal operational state. That's what we're here for. That's what AWS is here for, to help you out. So if you have an issue that you have a question about that may be impacting your operational state, we'd rather have you file a ticket with AWS support that turns out to be a non-issue than have you not contact us and then it turn out to be a real issue. So anytime you have an impact or a potential impact, contact AWS and reach out to us. There's sometimes that you have to contact us. This is some examples. So contacting AWS security, you need to, if you're going to do pen testing, we're monitoring our network, and if we see anomalous behavior on the network that we're not expecting, we're going to take action with that unless you tell us that, hey, I need this window open to do penetration testing. If you find a security vulnerability, or if you have suspicious emails or any kind of abuse, we want you to contact AWS security right away. As far as engaging AWS support, every AWS customer has support. That comes with an account in AWS. It ranges from basic support, which is free, all the way up through developer, business, and enterprise support, and you should take advantage of that support whenever you need it. As far as talking to somebody on the other end of the phone, it's a human being. This is just a mapping of, for example, roles on the ITIL side with incident analysts, managers, and subject matter experts to somebody who you would you may talk to in AWS. For example, an incident analyst might be a cloud support engineer. If you have a technical account manager, in some cases I function as a technical account manager for my accounts, and so I'm work on behalf of my customers as the incident manager should they need to contact AWS support with the need for us to do something and act on their behalf. So if you need to contact AWS, it's as simple as going to your web page, and there's literally a button on there that says, contact AWS support. That's all you need to do. That gets you immediately in touch with AWS, whether it's a security incident or anything else that you need to do to sign in for a ticket. So summarizing up here, good IR, good incident response, no accident. We recommend that you build securely, verify before deployment, build in all of that telemetry, monitoring, alerts, and messaging, analyze and preserve your data, use all the tools that we give you. One of the things that's great in the cloud is that you can, and we highly recommend, is that you build in a quarantine forensic security group. If you suspect an instance has been compromised in AWS, you can immediately change its membership in a security group in real time, and that instance will be untouched and quarantined and available for forensic analysis. I know one of the things that when I was working in a data center that we always had issues with forensic analysis was wanting to preserve the scene of the crime, so to speak. If we suspected a compromised instance, we wanted to be able to look at it in a pristine, compromised state. And anytime you had somebody logging into the box with root credentials to try it or doing something with it, we're always questioning what in the logs was real and what in the logs wasn't. With AWS, you can do that without even, it's like changing a security group is like cutting a network cord on an instance. Very, very powerful way to do forensics. And one of the things that we always talk about is, as I said, we're running these flight simulators, running an incident response simulation in the cloud to do this over and over again to train, because in the military, troops fight the way they train. And if you do not train for incident response, if you do not regularly do these realistic simulations, you are not going to be prepared. One of the reasons why I have this picture up here for US Air Flight 1549, the Miracle on the Hudson, is, and that incident was no accident. The reason why is because the guy flying that plane, Captain Sullenberger, has been training for 30 years for that moment. And he has had the ability, nobody had to look up in the books and page through thousands of pages in the manual to figure out what he needed to do to get that airplane down safely. That's the approach you need to take with incident response in the cloud. You need to have your folks trained and ability. You do need to have all that documentation in back of it, but the folks need to be ready on the ground to perform their incident response in a way that's going to get you back in business as quick as possible. Some objections for running IR simulations: expensive, high risk, can't afford to do live fire. On-premise, that might be true, not in the cloud. You can build full IR simulations, tear down an environment, you only pay for what you use. Very, very economical to do that. Why you should do it? If you're already doing incident response, all you need to do is take what you're doing now, build into the, take advantage of the cloud, and go there. The other thing that's, when you're using incident response for continuous improvement, and you're not just doing this as a once-a-year exercise or in a reaction to an incident response that's real time, you're never learning when you're scrambling for a real incident. You learn a lot from these things. Doing incident response on a continuous improvement basis helps you to learn and understand your AWS environment. It augments your readiness. As I said, troops fight like they train, and if your troops are training regularly for incident responses, when they come up, everybody, it's not a fire drill. People know what's going on, they know what the policies, they know what the procedures, they know how to run the playbooks on it. And also, when you do incident response, it does help you fix issues, because you're gonna have, when you build those IR scenarios using the expert users, your customers, the scenarios, the what ifs and so forth, you're gonna find problems, and you're gonna be able to fix those problems much faster than somebody that compromises one of your instances and gets it. So some resources that I have you can use, some other resources. And with that, I'd like to introduce my colleague, Conrad Fernandez from Johns Hopkins Applied Physics Lab, is going to talk about what they do for cybersecurity there. Conrad.
Thanks, Jim. Well, thank you, Jim. So I don't know about the rest of you, but did you catch the fact that Jim has been a pilot for 40 years. So I don't know about you, but there are 2 points I want to make about that, and Jim doesn't know I'm going to say this. But the first point is that he's been operating in the cloud, or clouds, longer than even Andy Jassy or Jeff Bezos, for that matter. And while that might be a little funny, I think the second point I want to make is that he is a skilled operator, and everything he talked about Sully and the miracle on the Hudson also applied to him. I mean, he's very humble. He didn't talk about getting out of tight situations and spots with smoke in the cockpit, things I think I'm allowed to share. But I want you to keep that in the back of your mind as I talk about Johns Hopkins APL's method as, from a customer viewpoint, to put that in the back of your mind, because everything he said was absolutely true. And that is, incident response is really a matter of preparation, training. If you do all the heavy lifting up front, trust me, as you will see in the rest of my presentation, it'll be so much easier. And we have some updates from the last time we presented this topic. Just quick background, so you know a lot about Jim. I'm Conrad Fernandez. I'm a cyber, I guess whatever it says there. I do a lot of things for the lab. A researcher, threat analyst. I've worked in security for the last 20 years, some in the bowels of the US government. I have very little OPSEC. If you've tried to look for me, it'll be hard to find. And actually, that's testimony to the fact that I'm here today to talk about something I never thought I'd stand up on stage and talk to you guys about, moving security to a cloud, because we've only worked on on-premise systems. I'm with Johns Hopkins today, but before that I was at Booz Allen. Worked with them 7 years. Oh, there you go. We got some boozers here. That's awesome. That's going to be a fun session, I'm telling you. And the point is, we've gone from being covert, we've gone from hiding everything to being more overt and sharing, but still being extremely diligent with that shared partnership with everything Jim talked about and all those laundry list of attestations. I don't know about you, I don't even know half of them. But if FedRAMP is saying, Amazon is great, then the rest is our responsibility, which is, just so you know, that's what I'm going to be talking about, is our responsibility in the cloud. So without further ado, so for those of you who don't know who Johns Hopkins the Applied Physics Lab, we're based out of Maryland, Central Maryland. We are a university affiliated research center. So we're very similar to the MITREs of the world, if you're familiar with them. But essentially, we are a not-for-profit organization that is really about technology. We work with deep space. We work with air and missile defense and a number of sectors in the United States government. And you can definitely look us up now that you know at least a little bit about Johns Hopkins. Moving along, so what do these sectors that we have at APL require? Well, we do a lot of forward research for our sponsors, and so it is important to think about scaling and scaling fast. For example, we do a lot of projects for research, do machine learning and EMR. So I've put in the human readable text on your left and the symbols associated with Amazon on the right. And all these are things that we've adopted because they've been extremely useful. And that is scalable computing and storage. And I especially love the second characteristic with agility, because we really can move very fast with CloudFormation templates. Those are the icons, by the way, on the right side. And we can pre-configure AMIs. We can bootstrap a whole bunch of applications on them. It just makes it so easy with all the automation, while still maintaining security and governance. That's originally where I came in before I started working on DevOps and all those other things that we're not talking about today. But making sure you understand that you have that capability. And last but not least, compliance to regulations and laws, because we have a lot of sensitive data we handle at the lab. CUI, FOUO, we work with Johns Hopkins and other medical projects from IARPA that have patient and EPHI, for those of you who are familiar with electronic protected health information. All that's super sensitive. Yes, my perspective is from DoD because I worked with them the longest, but this can apply to any of your sensitive information. So, when we started our journey, actually we still only have a very small cloud team. We're pretty Spartan, as you can see from the figure. And as I'll allude to later, you don't need a very big team. You can stay agile as long as, for example, the type of people we have, even though there are few, 4, maybe you can see 4 on this slide, we really are 4 or 5. But everybody is almost equivalent of the security architect, because we've professed to understand the cloud really well. And we work with people like Jim. We have a TAM, which is the technical account manager, other solutions architects, and Amazon's been great when we reach out to them for additional help. And we've come up with reference architectures. Obviously, this isn't APL's, but it's a notional example of the type of infrastructure we've set up. And the last bullet talks about the security posture, and not just the controls that was on an earlier slide, but also the monitoring and incident response. And that's a good segue to the next slide, and that is I'm going to be talking about incident response, but before I do, I'm trying to make the distinction between IR4 and IR9. Jim set it up really nicely in the beginning when he talked about the entire families, but again, the focus is on the actual handling. And just to be really clear, you know, life's a breach, right? For those of you who are familiar with all the statistics, you know, 707 million, it's probably 1 billion today and counting, you know, the number of breaches. But how many people here use sensitive data workloads in the cloud, whether it's commercial cloud or US Gov cloud? A show of hands? Wow. Okay, that's great. So a lot of you. How many of you who've had your hands up have responses, including spillage, for IR9? Wow, that's what I figured. There's much fewer. So hopefully this talk will help, and that's, I guess, why they've asked me to talk about IR9, because you may not know it now, but if you're handling sensitive load, including patient data or what have you, if you don't use some of the techniques I talk about, you are definitely operating at risk, especially if you don't have what we call an approving authority that tells us we can operate super sensitive information that could be classified. So spillage technically is classified material that it may not be identified initially as classified, but later on could be. And so you want to basically have spillage procedures, which we will get to. And part of that is having a phased approach. So this is the kind of phased approach we've adopted at the lab. Preparation, we'll be talking about that a lot in a minute. Identification, where you can detect. Containment, where you isolate it. Investigation, if you need to find out the extent of the spill or the incident, followed by eradicating the incident, recovering from it, and finally following up. Again, keeping in mind that last bullet there, this is applicable to IR4 and IR9. So, starting with the first one. You really want to pay attention to all these things that were even mentioned earlier, and that is enable logs, do the training, so this is IR2, do the testing IR3. But the other things I wanted to point out is the collection and the analysis. So we, for example, use Splunk. You could use Elasticsearch. You could use CloudWatch. There's a number of tools to essentially understand exactly the extent to which the spill or the threat, follows. So definitely pay attention to that. This slide, okay, so how many here today heard or can remember what Werner Vogel, the CTO, said? What did his slide on encryption say? Does anybody remember from this morning at the keynote? Anybody? Yeah, go ahead. Ma'am? So for those of you who didn't hear her, she says, dance like nobody's watching, but encrypt like everyone is. Well, I would say, that is, where do you think he got that from? He took a page out of the slide. He stole my slide. No, actually, I'd love to steal his slide. But it's funny because obviously we prepared this before. We heard him talk, but this is one of the key things that you really have to pay attention to. In fact, I would venture to say, if you get nothing else out of this my presentation anyway, it is this. This is one of the most important things if you're dealing with spills, and that is, I know he made a very generic statement, but you will see in a minute why this is very key. In fact, I've actually presented a few options whether you're using the types of persistence for the types of spills that are normally had, and that is EBS volumes, which is your C drive or D drive, and the strong recommendation, and just so you know, at APL, we're going to mandate this, but I can't mandate this for you. Having said that, if you are preparing your system to be fully encrypted, just like you would laptops, you will be in a great position. For S3 storage and S3's objects, there are a number of options Amazon makes available. The easiest one is server-side encrypt S3, which is literally a UI and you check a box and Amazon manages the keys. Or if you wanted more control for your customer master keys, as it's called, you could either use Amazon's KMS, or you could also roll your own encryption through your own cloud HSM. Hopefully that's a FIPS 140-2 compliant device where you're running AES 256, at least one of the algorithms from the Suite B set of algorithms. And you can have Amazon use those keys to encrypt the data. But the point is, and you can read up more on these online, they definitely have a lot of information on those three types. Then, so here's another thing I want to introduce for preparing your environment is using something like AWS Organizations. You don't have to, you can do this yourself, but we found this super helpful because there's two things you get out of AWS Organizations. You can limit your blast radius by having different accounts that are aligned by projects or your departments or departments and projects, kind of like the tagging that Jim referred to earlier. You can organize it that way, and you can also use service control policies. So I give this very simple example where you can have a policy where all the logs you're collecting don't accidentally get deleted, And since I mentioned encryption in the previous slide, you should have a policy that has, make sure that anything that lands in S3 or any EBS volume that's getting created should be automatically encrypted. And this is just a snapshot of what it looked like. And that is on the left side. So on your left, it's the list of projects, sectors and projects, or we call them sectors, but departments and projects, or however you organize your accounts. And on the right side is a bunch of policies like HIPAA and various service control policies that you can apply against these accounts. It's a multi relationship. Okay, so enough of preparation. So now we've moved on to the next phase, which is detection. We won't spend a lot of time in here because, again, the focus is on IR9, which is spillage. Most of the times you will be informed. Yeah, I know there weren't a lot of hands raised, but if that ever happens, typically you will be informed that that there was a leak. This is very different than trying to identify which threats are rooted in your system. That's a whole different talk. That's not this talk. And in fact, I mentioned things like SIM tools that you can use for your regular adversarial threat in nation state type of thing. Here, this is more like you can also use Amazon Macy, which was recently announced, to do the equivalent of your data loss prevention, your searches for certain sensitive words. And last but not least, we're recommending you don't have to reveal a lot of information about the case, but you should open up a case with Amazon and using the various support levels that Jim talked about earlier to ensure that you can verify that any of the spillage response plans, like the deletes, are verified by the Amazon counterparts. And so it's really cross-validation. Oh, here's just since we use Splunk, for those of you who use Splunk, this is it's just a dashboard. The point is you can use the dashboard and your alerts. The alerts is where the payoff is, honestly. Otherwise, it's just a pretty picture. But that's where the folks that know what to look for, that operate this part of the cockpit, so to speak, will know what to look for. Maybe not so much for spillage, but certainly for threats. I combined the next two phases in the interest of time. The main focus here is on containment. 2 points about containment. Number one, it's speed of how quickly you do it. And so speaking of speed, you do have automation. I've given a simple example here of the CLI. Amazon has CLI and SDKs. And in this case, this is a simple example for how you can modify the security group that's associated with that instance so that you isolate it. And the isolation rule in this case is fairly isolated in the sense that only ports 22 and 3389 are open. And that way, people who have to do the remediation can go in, but nothing leaves it. So it's basically tightened. And hopefully, folks are familiar with at least this concept, if not how to write it, how to write the code to do that really quickly. Oops, did I go backwards? Investigation. Right, so investigation is only defined at the full extent. For those who are familiar with using either Elasticsearch with Kibana, or in our case, we use Splunk, then you would basically search for wherever that resource or artifact or the person that who all have accessed them. That will give you all those relationships that's shown here because it's a correlation tool. So it'll give you the full extent. Okay, so this is the payoff, right? Everything I talked about encryption, this is the payoff. If you did use encryption, this is an if-then else, by the way. If you did use encryption, then now you just do the inverse, and that is you're basically doing key management. So for EBS, what we're recommending is that at least this is how our policy works, and would be approved is you can't really do the wipe procedures from DoD 5220. So what we're doing is copying only the good files over to a new encrypted volume. In other words, you're only taking what you want. It's like moving house and leaving all the crap behind. Whether it's free space, slack space, and all those things you would have to wipe. Instead, you only move the objects you want, that's good, and into a new volume, and then you delete that old volume and the key that's associated with that volume. Ditto with the S3 for your S3 objects. If you use SSE S3, that's really simple. You just delete the key. Just delete the object because Amazon manages the key. If you use KMS, then obviously delete the object and delete the customer master key that you used to create that object. And if you rolled your own key with the SSE-C option of encrypting your server side, well, same thing. You'd have to go back to your on-prem, or whatever modules you've used, Cloud HSM, and then obviously delete those keys. So this becomes essentially key management. The good news is everything is in cipher. Your accountability should be so much easier if you use encryption. So I know the CTO didn't say that, Werner didn't say that this morning, but this is an actual instance of where mandatory encryption can really save your arrears if you've done it up front. If you've not, I don't want to pay a lot of attention to this slide. I know some people still want to see the BC wipe. I'm not sure it makes a lot of sense. on other than magnetic media storage. And today everyone's using SSDs. You could try and use BC wipe, using a secure copy on that. You remember we talked earlier about only opening ports 22. And so you can use SCP to copy your wiping utilities, whether it's SDEL, BC wipe, whatever your wiping utility is, and then SSH to the host and then run the utility. Okay, so we're getting towards the end, right? So the good news is we did all the hard work in the previous stages. So now recovery is just a matter of, like, in the old days, you just have to return the machine, and that can also take a lot of time. Now all you have to do is programmatically restore the security group, and whoever's machine that was can happily go about using their EC2 instance. That's the really good news of having the instances in the cloud, is it makes the restoration so much easier than for them waiting for it to be carted back to their office. And again, give an example of how to modify the instance using the CLI. And last but not least, I'm not minimizing it, but there's a lot of follow-up typically for either threat case, whether it's adversarial threat or in this case spillage, because you still have to, at least from the DoD's perspective, there's a lot of accountability for how you did it. But again, if it is encrypted, you're in a great state. And so key takeaway is from all of this is just a summary. And that way I can give you some time for Q&A and have Jim come back. But here are the key takeaways from my part of the presentation. And that is to understand the difference between the two types of threats. Use a phased approach, whether it's 6 steps, 7 steps, whether you combine them. Pay special attention to preparation. That's the most important. That's where those bullets are. If you noticed, encryption is like #1 for us right now. The other ones are all definitely nice to have, and you should have them so that when smoke appears in your cockpit or geese fly and take out your engines, right, you're not panicking when you're accustomed to failure. And so those are all good to have, including your dashboards and visibility. And last but not least, you can have a small team. As long as they're competent, you know the resources to reach back into, you can be agile using all the automation that's available to you, along with the good processes that you've put in place. Hopefully, these were good insights that you can take and start practically trying to implement in your own fashion, when you get back home, especially after this long week. And with that, thank you for your time. And And I'm going to have Jim come back up so that we can answer any questions that you have. Oh, question. Yes, please. Oh, could you use the mic? Because even I can't hear you. Oh.
Thanks for the talk.
Yeah.
I believe some of the child requirements for IR9 require information sharing with the agency that you're contracted with. Have you had to deal with those types of requirements?
Do you want to take, is this with the agency? So are you talking about the sponsor?
Correct. So I think there are child requirements to IR9 that require information sharing. If you have certain data types, I believe it's part of the CUI recent announcement that the regulators have made.
Right, so AWS, and I can speak for Department of Defense and federal civilian agencies in regard to that. So part of our authority to operate that we have been issued by the government, by the FedRAMP Joint Authorization Board, requires compliance in that area. So for example, we are required to report and share through US CERT, US Cyber Command, DibNet. So all of that information sharing is part of our security and compliance, and it's required for us to maintain that. And I can't speak for other accreditation regimes, but I know with the federal accreditation regime, with the NIST 800 control sets, that yeah, that's a requirement that we do that.
Okay. That's at a more an Amazon level. What about at your organizational level within Johns Hopkins research?
So we do share our procedures are definitely shared with the sponsor, right? Because APL has a lot of sponsors, you know, like I said, all across the United States government. So it's not only transparent to us and our projects, right? Because we have people from Space Department or people from, you know, Air and Missile Defense. And so they all come, or force projection. We're essentially a Navy installation, so we have to do a lot of underwater, you know, warfare. And so they come to us and saying, what is our incident response, which includes obviously the spillage piece, only because it has happened. There's a lot of spills. They will happen, and so we share. We're very transparent. So we're not only transparent to our customers at the lab. You know, since we're IT, we have customers at the lab, but their customers or clients, right? The rest of you folks have clients. And so we're totally happy to share it because, again, it's all in full transparency. We have to report it. There's nothing to hide. In fact, if anything, a lot of stuff is made public. I mean, not public, but it's reported to all the authorities. In fact, if you were HIPAA, you actually have to even, I know you didn't use the HIPAA example, but if you breach the HIPAA rule, in other words, if you have patient data that for whatever reason escaped, you would have a lot of explaining to do, not only to the authorities you represent.
Over 500 records, most states require notification to the state attorney general.
Yeah, so, you know, that's the whole reason we're talking about this is this is a semblance of our actual, well, I mean, obviously we don't have the details of how we manage the keys, and I didn't talk about, we do roll our own keys as well. So I'm not giving you those levels of detail other than saying here's our process so that we get approval from our designated approving authority, you're right, and so and we can tell our sponsors we have approval from DSS, who is our designated approving authority, that they've said, oh, these are great procedures, and it's made available to all our customers.
Great, thank you.
Sure. Is there any other? I guess we're. Sure. That's great. No, we got a couple of minutes.
So great talk, first of all. Thank you very much.
Thank you.
You mentioned some really good best practices around forensics for EC2, for S3. Any forensic best practices for, say, RDS or CloudFront, in case those services get a spillage, as you put it?
So we're not yet using RDS for government-sponsored projects yet. And so I wanted to cover the most common use cases. It's a great question. In fact, I didn't get a chance, you know, in the limited time, you know, for my part of the presentation. I definitely wanted to solicit feedback from the rest of the audience after this, because obviously we won't have time now. If there were procedures that people are utilizing for RDS and databases, right? Because we're not.
Similar to what Conrad for RDS. You know, we recommend, you know, he's recommending ubiquitous encryption everywhere. We recommend the same thing for RDS, is to leverage the native encryption of that database engine so that you make sure that, you know, in RDS you're responsible for the data lever. And for example, when we get what's our area of responsibility, for example, when we get a compliance order, whether it's an IAVA or a TCTO or a patch release from the database engine manufacturer, in the case of the commercial databases such as SQL Server or Oracle, or in the case of our own, we are going to notify you, and we suggest that you proactively take advantage of those patches and release as soon as possible. You're in control of the patching, and we're not going to break your application, but we're going to let you know, hey, you know, Oracle patch 12.c.1.3.5.7 is available. Please give us a maintenance window that we can apply this patch. And of course, everything else underneath that, where we are responsible for the controls, for example, with the operating system in that case and the database engine, you know, we are going to comply with that reporting regime, whatever it is. So, for example, if we identify vulnerabilities, you know, that's in our accreditation for those control sets, for those platform as a service, where we have, as a cloud service provider, greater responsibility at a higher level in the stack to go ahead and do that. So, you know, for example, you may have seen recently that Intel released a vulnerability for their hardware, and that falls into the environment that I talked about before earlier. One of those scenarios where you have a 0-day where multiple cloud service providers, so anybody's running Intel hardware underneath is going to potentially be vulnerable to this. This is a multi-cloud service provider response required. So, Amazon very proactive in that, and they come out and they do the analysis. They figure out, is this particular vulnerability that was announced affecting customers? And we have verbiage immediately saying, no issue for us. Or if there is an issue, we're going to say, here's how you respond to that issue.
Mm-hmm. Thank you. Great questions.
Thank you all very much for showing up so late on a Thursday.
Yeah, really. I'm shocked we have so many people still here.